Alright, students. Today we're going to talk about inscribed and circumscribed polygons. So we're going to do a construction of an inscribed hexagon here. So the first thing we need to do is create a circle with a diameter of 12 centimeters. Well, this says diameter, so that means that the radius is going to be 6 centimeters. So we're going to create a circle with a radius of 6 centimeters. Alright, and like I always do, I'm going to create a radius here so I remember that my radius is 6 centimeters. Alright, so next it says use your protractor and create an inscribed regular hexagon. So regular means that all the side lengths are the same length. It also means that the angles are going to be the same length, the interior angles. So in order to figure out what that angle should be, where am I going to put my points, I need to find the angle BAC. Okay. Well, I have A, so that means it's one of these angles here. So let's just say I'm going to start right here with B. So I know I'm going to have a BAC somewhere over here, but I need to know what this degrees is. So what is this central angle going to be? So I know that all the way around is 360 degrees. So 360 divided by my number of sides. Well, a hexagon has 6. So that means that each central angle is going to be 60 degrees. So I'm going to start by creating a segment AB. And then I'm going to create a 60 degrees angle. So using my center as a point, I'm going to go find 60 degrees over here, which is right here. And I'm going to draw a line there. So this is C. This guy right here is 60 degrees. So I'm going to do that all the way around the circle because this is 1 if I connect B and C. This is one side of my hexagon. So I'm going to keep doing this. So I'm going 60 degrees all the way around. So this guy is D. 60 degrees. There's 60 degrees. Oh, hey. Since this is an even number, that means I have diameters. So if this is an even number, that means all of these guys are going to go across. Well, that could have saved me a lot of work if I had thought about that originally, but that's okay. A hexagon is even, so I can use diameters. So that means I don't need to do any more measurements. I'm going to continue these lines all the way through. Now you can still use your protractor if you're trying to get the exact degrees. So this point E, this guy is point F, and this guy is point G. Remember, you always start labeling and go clockwise when you're looking at your shapes here. So now I'm going to fill in, so I'm going to use a different color. Let's use blue. I'm going to fill in my lines of my inscribed hexagon here. So here we go. Remember, it can only be diameters if, oh, this thing's bleeding. If it is an even number of sides. If it's not an even number of sides, you can't use diameters. You have to use the degrees. All right, so I have inscribed the hexagon B, C, D, E, F, G. Okay, now it says create triangle ABC. Well, I already did that. Using your compass, so I got to create a perpendicular bisector to BC. Well, that's easy to do. I'm just gonna put on B, put about halfway through, and I'm going to create a perpendicular bisector. Let's see, here we go. And here, go to C. Oops, I didn't make this arc quite big enough, so I got to redo it. Okay, so now I have a perpendicular bisector, and oh, look at this. My perpendicular bisector is an angle bisector. So that means these guys are 30 degrees. And that means these sides are congruent. Now this guy is okay, I'm supposed to label this point H. So these lines that go from the center to the points on the circle, these guys are radiuses. So I can put, this is 6 centimeters. This guy is 6 centimeters. Now it's asking me what is the length of AH. Well, to find AH, I'm going to have to use trig. Kiddos, do not use your compass. So if I took my compass and tried to measure this guy, I'm going to come up with 5.3. So let's see what it is for real. So if I use this triangle right here, this is the cosine, so I would be saying the cosine of 30 degrees is equal to adjacent, which is what I don't know, over hypotenuse, which is 6 centimeters. So if I put this into my calculator, I'm going to end up with, good question, I don't have my calculator. Let's see. I'll use my handy dandy phone calculator. So we've got the cosine of 30 degrees times 6 gives me 5.19, so let's just round that to 5.2. So AH is equal to 5.2. If you were using your ruler, you would have got it wrong. You have to use trig on this, kiddos. So then, if this guy is now 5.2, then I can find this total length of BC, because I can again use trig. I can use the sine. So I can say the sine of 30 degrees is equal to, well, I've only got HC, so I'm going to use HC over 6. So that means HC is going to be equal to, well, let's do this on our calculator. So I've got the sine of 30 degrees times 6 gives me 3. So that means this guy is 3. Now, HC is 3. Well, that means that CB is 2HC. So that gives me 6, which is equal to BC. All right. So when inscribing a polygon, it doesn't matter which one it is. The first thing you got to do is take 360 and divide by the number of sides that you have. That's going to tell you what this internal angle is going to be. Then you can start creating your points using your protractor. And then you can create a perpendicular bisector to one of your sides, and now you have a right triangle and you can solve for your side lengths inside of it. All right.